Let's get started solving the Truss equation. Use the method of joins to create river diagrams and solve all of the forces acting on each joint. Find the missing information, include labels. For external forces, identify if the forces are compression force or tension force. The laws are in pound. Let's get started solving the equation. So as you can see that I divide the page in eight section here. So I will start from left. So we're going to start from step 1. So in step 1 we will put the joints here. So we will have A, B, C, and we have D here. Okay, we have a roller support here and pin support here, and there is a 500 pound force is here. Okay, so I can, or we can do the, and our truss system is like that. And there is an angle between them is 63.4, and this is 45. So we're gonna count the boxes, and this is 2 feet, and this is 4 feet, and this is 4 feet height. Okay, remember, if there is a roller, there is a one reaction force, and I can show it like that. R, A, reaction force point A on the y direction, and if there is a pin support, there are two reaction forces. I can draw it like that: R, C, Y, and R, C on the x direction. Okay, so this is like, again, the direction here I chose them randomly, but when I start doing the calculation, if I get the positive, then the directions that I choose is correct. If I get the negative, then I have to change direction. Okay, right now let's look at if this is statically determined. So we look at this equation: 2 joint equals member plus reaction. Okay, right now let's apply that. So we have, how many joints we have? 2 times 1, 2, 3, 4. If this is equal or not. How many member we have? 1, 2, 3, 4, 5. Plus how many reaction we have? 1, 2, 3. 3 reaction. So as you can see, this is statically determined. So we can solve this question. Okay, so right now let's go to step 2. Maybe I can just put as 2, step 2. So in step 2, what we are doing is we are applying the total moment should equals 0, right? Because it is static system, it's not moving. And remember, moment is force times perpendicular distance. Okay, we are writing the moment for all point. Moment A, moment B, moment C, moment D, D equal 0. So right now, so we need to pick a point. So after that, we have to do the moment calculation. So here on point C, there are more forces. Okay, so I can choose this as a axis of rotation. Like I can take this. This can be my reference point, or I can say that this is my pivot point. So according to this point, I will write the moment. uh, I'll do a moment calculation. So moment C, this is, what do I do is I pick a point. I pick the point C. So just as a reminder, before I do the calculation, the clockwise direction we are choosing negative, and counterclockwise is gonna be positive. So right now, according to the point C, let's apply the moment. Okay, so if according to the point C, this force RAY try to rotate the system clockwise or counterclockwise. As you can see, it's try to rotate it in the clockwise. So we have RAY force times, what is the distance, perpendicular distance? It's gonna be 6 feet. And by the way, if this is making it, try to make it clockwise, then it's gonna be, this part will be negative. What about, is there any force? Is there any force right here on point B? There is no force, that's why it's gonna be 0. Is there any force on? Is there any moment on point C? There are forces, yes, but since the force is exactly on point C, then the distance will be equal to 0. That's why force times distance, this part will be 0. What about point D? Yes, at point D there is a 5-pound force, and it tried to rotate it clockwise or counterclockwise. As you can see, it's trying to rotate according to for point C. It's trying to rotate that counterclockwise. That's why it's going to be positive. 500-pound force times, what is the perpendicular distance? 4 feet equals 0. From that, when you do the calculation, you will get, okay, let me rearrange the system. R 6 feet equals 2000 pound feet. Okay, if you divide both sides with 6 feet, then R A Y will be, if you do the calculation, you will get 333.3 pounds. Okay, this is, you need it. Okay, so right now let's go to step 3. On step 3, right now let's apply the total forces. Total forces on the x direction should equal 0, right? So on the x direction, the total forces should equal 0, and total forces on the y direction should also equal 0. Okay, so here I am choosing up positive, down negative, or right positive, left negative. Okay, this is my preference. You can have your own preference. So first on the x direction, we just only have RCX. There is nothing to balance that. That's why RCX is automatically, without doing any calculation, that's going to equal 0. Okay, so right now let's apply this. So first on the y direction, we have RAY on the RAY is upward, and we have RCY upward, and we have a 500 pound force downward. It's gonna be negative. 500 pound force is gonna be negative, and that should equal 0. Okay, now We just found the RAY, right? So right now let's plug it here. 333.3 pound RCY negative 500 pound force should equal 0. From that, if you do the calculation, you will get RCY equals 166.7 pound force. Okay, so now as you can see, we found the RAY, RCY, and RCX. Okay, now let's go to step 4. Okay, for step 4, we need to go back to step 1, and in that we need to show the we need to start writing the internal forces. So internal forces, I would like to write them all as a tension force. So I'm going to assume that there's a tension here, there's a tension here, there's a tension here, tension here. Again, these are my preferences. Right now I am doing. Later in my calculation, based on the answer is positive or negative, I will change the direction. If the answer is negative, then I have to change the direction. And right now let's write this is AD, and this is DA, and this is DC, and this is CD force. And these are equal to each other, okay? And this is CB, and this is BC. This is BD and DB, and this is AB, and this is BA. Okay, so right now we are on step 4, and let's do that. So which point I can start? So I'm gonna look at the known and unknown. If I have two unknown, then it's not a good idea for me to do the two unknown. So I'm gonna start with one unknown. So here, if I start with this point, there are three forces. I don't know enough. I cannot find them. But here there are something that I know. Here there is something I know. I would like to start with point A. Okay, right now let's do it with point A. So I'm going to draw the point A here. Let me draw it small. And in point A we have R A Y, and we have this is A D, and this is A B. Okay, so right now let's write the component, and this is A D Y, and this is A D X. Okay, now I will try to find the unknown. So this is RAY is 166.7 pound. Okay,